Hello and welcome back. Today we're working on a Macbook Pro A2338. That is a Macbook Pro M1 2020, I believe. And the symptom this one has is that when you connect the power supply, either on the top Type-C port or on the bottom one, it shows 5 volts and 450 milliamps. So either I'm going to be lucky and it's going to be a cap, or I'm going to be miserably unfortunate and we're going to be here for 3 hours. So without further ado, let's try to disassemble this one and take a look inside to see what is going on. This is one of the simple laptops to disassemble, so if you want, you can either stick along and watch the entire process of disassembling it, or rather fast forward it, or skip the entire thing. Let me get a magnetic pad, because why prepare? Okay. This should be a normal procedure by now. So suction cup, lift, and pull away. And you can get rid of this. First thing we always do, disconnect the battery. Good. And for the sakes of being extra careful, let's remove the battery screw as well. Let me see if we're gonna be lucky and if we have a short on the main power rail here. And of course we don't. Why would we? Moving along. I will remove the logic board from the chassis and take a closer look at it in case there is some liquid damage or any components that are misshapen or blown or whatever. And then we will start measuring around to see if something is shorted or not functioning or not being fed power to it or whatever can be wrong. Just removing the visible screws on the logic board so that we can remove the shields covering various things, like this one, and like this one, which is covering the LCD cable. There are actually two covering the LCD cable because it needs some extra protection, because God forbid Apple made a mistake of making the LCD cable or the LCD cables too short. And they break when you open and close the screen too frequent, or you know what I'm talking about. Just disconnecting every component and every cable there is here. We need to lift this. By the bending of this, I'm guessing someone has been here already, so yay. Lucky me, I'm gonna have a good time. Let's remove the antenna cables there. And I think all that is left is the shield here, covering the Touch ID power button. It has a screw here as well. Let's see if this... Nope. Okay, this should disconnect as well. And there we go. Let's see if there's any signs of liquid damage. Nothing too obvious. let's remove this out of the way, and I need the USB-C ports here, so I'm going to take those out as well. And let's take our chassis away. Now, judging by the current it's drawing, there should be something getting hot because it's like half an amp. And since I'm going to walk you through my standard procedure of measuring around. Is this visible? Yes, it's visible. So first thing I do when I see the output of the amp meter like that, I mean like 5 volts, not switching to 20, is I always check this fuse here, which seems to be okay. The fuse itself is working, that's good. And we have no short to ground, neither on this side, which would be the same since the fuse is working. So we have no short on the main power rail, which is the PP Bus G3 Hot. And since this is a board that works with the CD32 17s, we can measure the LDOs on these chips. And if you measure something out of the ordinary, something like a low reading, it means that one of the chips, or maybe both of them, are not working properly, or are damaged, or shorted, or in a huge need of replacing. Now, as I said before, if something is drawing 500 milliamps, then something should be getting warm. So let's turn on our thermal camera. Okay, and let's put this here. Let's start from this side. Okay. Nothing special here. Okay, something's getting hot there. Okay, let's turn it around. Okay. Okay, there are 2 places lighting up. Okay, let's remove this. I think that we might be actually lucky, because the area that was getting hot, the one was here, and the other one was in this area, which is mostly made of caps. Let me get this in focus. And I think we have a winner here because it's actually visible through the microscope without needing to do anything else. Can you see that little guy there? You see that he is broken here? Yep. So we were lucky after all. Let me bring this here and measure that cap. Oh yeah, that's definitely shorted. We don't need to do any freezing and injecting the voltage because we can actually see that that cap is shorted. So let's get a door board. This one should do. And remove that cap and apply a little bit of flux, just a little bit, like so. Turn on our fume extractor, and now let's remove the cap. just put it back where you remove it from. What is this? Is this the bad one? This is the bad one. So our cap flew into another universe. Oh, no, there it is. Let's measure this one to be sure. What does it say? Okay, it's not shorted. I think I should apply some fresh solder there because it's kind of hard to melt. Where is it? Come on. There it is. Let's apply some solder here. And this is the ground pad because it's way harder to melt. And in case you make blobs, you can always add some flux and correct them. And now let's get our cap, which was here. Rotate it so we can get a better grab of it. And this should go straight. Good. If you're a perfectionist, you can add some more flux and gently press the solder there so it looks nice. Good. Now let's get a Q-tip and some alcohol. And rub this thing around so we can clean the excessive flux. And let's hope too many things blowing and sucking air, of course. Let's measure. And we'll put this in the center here. So if we measure, I'm not measuring correctly, obviously. Now I'm measuring correctly. Okay, there's no short there. So if, that's a big if. Okay. Stop this, get this out of the way. Let's see if we connect the power supply now, if it's going to switch to 20 volts. Oh, there's no more 450 milliamps. Switch to 20 volts. It's perfect. Let's reassemble this and check if we were indeed that lucky. Well, I mean, we were, but you never know if it's going to have another problem. It might not have brightness on the LCD because the backlight circuit is not working. You never know. With this specific board, I always try to reassemble it by sliding the logic board this way because this is kind of hard to work around. And then you can just start lifting every connector and every flex cable, like so. Nothing too fancy. And then it just sits there. Let's reconnect everything. Okay. Don't ask me why. I always am positive and reconnect everything. Even though it might not be working, then I might need to remove the logic board again and do this entire process all over again. But if everything does work, then you don't have to do anything else. You're ready to go. Come on. Okay. What's left? The trackpad cable. The keyboard cable. Come on. Okay. Okay. And let's connect the Wi-Fi antenna cables as well. And the LCD cable, of course. Okay. And let's give this a go. Oh, it did switch on. Let's put it like so in case it has something we should not be seeing. Yep. I'm gonna put a sticker on the username so that you guys cannot see what it says. Come on. No, you should. No, this is not working. Anyway, you can trust me. It is working. See? Well, that's it. I hope you learned something, and I'll catch you on the next one.